Welcome Pythonistas to this tutorial where I will show you the full Python Web3 stack to start building in Web3. Vyper for your smart contract, Ape for your smart contract development tool, and Web3.py to interact with your smart contracts. Let's go. The first thing I'm going to do is create a virtual environment. Go ahead and activate the virtual environment, and then we're going to install 3 libraries. Vyper for our smart contract, Ape for our smart contract development, and Web3.py to interact with our smart contract. Pip install Vyper, Ape, and Web3. One more thing, Ape works with plugins, so it's very bare bone. Now we need to tell Ape what smart contract language we will use, in this case Vyper. So we're going to go ahead and install a plugin for that called Ape Vyper. The next thing that we're going to do is create our Ape project. I'm going to go ahead and name my project hello. There we go. Now head over to your contract folder, create a new file called hello.py. Py is the extension for Vyper, and over here we're going to start typing our smart contract. So the first thing that we're going to do is define the version. And you need to define it within a comment. Version 0.3.0. Now let's talk what this smart contract will do. We're going to define a variable, and upon deploying the smart contract, set a value for that variable. This is going to be a basic smart contract just so we can get started. Quick note about Vyper. It's Pythonic, which means it looks a lot like Python, but it's not exactly the same. But don't worry, it's very easy to use and definitely feels familiar if you're coming from Python. So let's start with defining our variable greet. We'll give it a visibility of public. We'll talk about this in a bit. Then give it a type string with 100 characters. All right, so what's going on here? We named our variable greet, then we set public. What does that mean? When we deploy a smart contract, variables can be seen or not seen depending on what visibility we give it. Now don't worry too much about the different types of visibilities. Right now we've named it public, which means anyone can see and call the value of greet once we set it. Next up is a string. Now strings are a bit special in Vyper. We also need to tell Vyper how many characters this string has. Now this is unique to strings. If you would create a variable, my favorite number, set it with a public visibility, you could just say uint256 and that's it. The same goes for a boolean, when you would have flag, public, set it at bool. That's it. Now we're going to use a special function called a constructor. A constructor is a function that only runs once when we deploy the smart contract. That's it. And a constructor is always defined like this. Def __ init __ and that's it. Now over here we're going to define the value of greet and we're going to set it to hello world. Now you're seeing the self keyword here and you're obviously familiar with that. Self usually refers to the instance of the class. In this case, it's referring to the smart contract. Now the only thing that we need to do is give this function a visibility. Now there are 4 types of visibility a function can have. Public, external, internal, and pure. If you want to know more, I've got a link in the description down below with an article. We're going to use the external one, but I'm only going to touch on public and external, and in future, we'll dive more into it. So don't worry too much about it. Public functions can be called internally and via transactions. External functions can only be called via transactions and not internally. What this means is that an external function can only be called when, let's say, you send a transaction to a smart contract or you deploy a smart contract, which is also a transaction. So in this case, what we're going to do is we're going to set the visibility of our constructor to external. That's it. We've built our smart contract. Next, what we're going to do is compile and deploy the smart contract. So let's go ahead and type ape compile. This compiles a smart contract. Whoops. And we're getting a bunch of errors. Now I had a slight error over here, a syntax error over here. Okay, the error is fixed. Let's go ahead and type ape compile to compile our smart contract. And there we go. You can see this build directory that just got added to our project. Go to hello.json. It contains the ABI, which stands for Application Binary Interface. It basically has all the functions, all the data and variables in here, together with a bunch of other stuff. Today we're just going to focus on the ABI. So if I click on the square bracket here, you can see the ABI goes up until here. This is the ABI. We will need this later on. Next, let's deploy our smart contract. Now there are 3 ways to deploy your smart contract. You can run a command in the terminal and pass your private keys. Not so safe because anyone can see your private keys. You can use a .env file and load your private keys, but if you accidentally commit your private keys to GitHub, people have access to it. Or you can use a script and combine that script with encrypting your private keys through the terminal and protecting with a password. This is best practice, so that's what we're going to do. I'm going to go ahead, head over to my terminal and type ape accounts list. This shows you a list of all the accounts that are available to ape. Now, if you want to import your own account into ape, you can do that by typing ape accounts import, give it a name like MetaMask1 if you're importing your account from MetaMask, and then you'll be prompted for your private key. I've already done that, so I'm not going to do it. And after this prompt, you'll be prompted for a password. Now, next what we're going to do is we're going to create our deploy script. So I'm going to go ahead and type in deploy.py, and over here we're going to start building our deploy script. So first what I'm going to do is from ape import our accounts and project. All right, next we define our function, and the first thing that we're going to do is load our accounts, and I called mine scroll sepolia, scroll sep, because I'm going to deploy to the ZK rollup layer to scroll. Next, I'm going to use my account, deploy the project. The project was called hello. And then after this, we can do a print statement saying deployed. Now we're going to make one more adjustment. We're going to pass a keyword argument to our deploy function. And this has to do with the fact that not all chains support EIP 1559 transaction. If you don't know what that is, don't worry too much about it. It's a new transaction structure. Scroll doesn't support it right now, but it will in the future. But you might run into these kind of issues. And I want to showcase to you how you can use the deploy function to alter the deployment of your contract and adjust it if necessary. So over here, what I'm going to do is define the keyword with the key type, value 0, and then we can pass it over here like this. Awesome. I'm going to head over to the terminal and I'm going to run this command, ape run scripts deploy.py to the network of scroll Sepolia. If you're wondering where I got this RPC URL from, you can head over to chainlist.org and search for scroll. And then if you include testnets, over here you can see the scroll Sepolia testnet. And then over here you can see all the RPC URLs that are available. You can copy one, paste it over here, and you can also connect your wallet and add it to MetaMask. Awesome. Now let's run this command. Cool. So we're connected to the network, the scroll network. We want to sign this message. Yes, I'm passing my password and then I don't want to keep it unlocked. Boom, there you go. We deployed our smart contract. So the next thing that we're going to do is we're going to take this smart contract address because we're going to need it later on. I'm going to save it in a text file and keep this for later. Awesome. We've deployed our smart contract. The next step is to interact with our smart contract. Now, upon deploying the smart contract, we've set the value to hello world. Let's go ahead in our repo, create a new file and write a script to print hello world in our statement by reading greet. I'm going to name my file hello contract.py. Now we're going to do a couple of things. First, I'm going to import JSON. I'll need this for my ABI. Next, from Web3, I will import Web3. This is our Web3 library. All right, first we're going to define our RPC URL. This is our connection to the blockchain. Next, we're going to make a connection with our blockchain by using the Web3 library, and to the HTTP provider, we're going to pass the RPC URL. Awesome. Now we're going to load the ABI. Remember, I mentioned the ABI before. The ABI is the application binary interface, and it basically contains all the variables, functions, and data types for our smart contract. So over here, I'm going to come, click on the ABI is until here, copy this, go to my hello contract.py, save it, and there we go. Next up, let's define the address. We saved our address in the contract file, and now we can get to the fun stuff, which is we want to query what the value is of greet value. Now we can do this by utilizing contract functions and then greet call. Now remember, we set the visibility in our smart contract of greet to public. This means that we can call the value of greet and anyone can like this. And now I'm getting an error here, and that's because I forgot to instantiate the contract, which you can do like this. Contract Web3 ETH contract, and then address is address, ABI equals ABI. Awesome. Finally, what we'll do is we'll print the value of greet value in our terminal. Let's review. We imported the necessary libraries, made a connection to the blockchain, instantiated the Web3 library, loaded our ABI, got our contract address, instantiated our contract, and called the value of greet value inside of contract. Okay, cool. Now, let's see if this works. Python, hello world, or hello contract.py. Awesome, it works. Hello world. Now, we had to do something annoying, and which is copy and paste the contract address, and we had to do it manually. And sometimes you'll deploy, and then you clear your terminal, and that's very annoying to get back the history. Now, there are other ways you can list out the history of your terminal, but we're using Python, and the beauty of Python is that you can automate. Let's go ahead and adjust our deploy script so it automatically captures the contract address with the name and timestamp inside a text file, so we can go back and look. If we search for a specific contract, it will be there. We don't have to manually save it. Our script will do it for us. Go ahead and define the contract name first. In this case, that was hello. Next, what we want to do is pass it dynamically to the deploy function. We're going to utilize the get attribute function for that. So we've got the project and then the contract name. And then over here, what we're going to do is pass the contract class. Now we need to give this a name. So we call this deploy contract. Then we can come over here and say deploy contract dot address, and this will be the contract address. Awesome. Next, we need to grab the current time for our text file, and in order to utilize this, I need to import datetime from datetime. Save it, come down, and then we say datetime.now, and then we can format it in a certain way. I like this way, so I've got a standard way saved up. Then with open our text file, if it's not already, if it doesn't already exist, it will create it. We'll call it deployed contracts.txt and then as file. And then we want to write to that file. And what we want to store is the current time, the contract name, and then the address. Awesome. I've also added the print statement with the same data over here. So we also record it in our terminal or output it in our terminal. Okay, this looks pretty good. Let's go ahead and try to run this by running our deploy script again. We're connected to our node. I want to sign it, enter the password, no. Awesome. We've deployed our contract, and over here, we can see a text file with our timestamp, the contract name, and the address. That is awesome. Now, we can even further improve this script, and let's go ahead and do it. Over here, we can say input, and then ask what is the name of the contract. Now, if I do this, I can just copy and paste this script and add it to any ape project that I want. Because over here, what I can do now is if I run this script, I will be prompted for the name of the contract, which is hello, enter, sign, password, no, and there we go. We've deployed our smart contract, and we can utilize the script over and over again. All right, Pythonistas, that was it. I hope it was of value to you, and I hope you enjoyed it. In the next episodes, we'll dive deeper into more complex Vyper contracts, testing and deploying, and awesome scripts in Ape, and actually creating transactions using Web3.py. Stay tuned. I hope to see you guys in the next one. Take care.